Now in this lecture we will discuss the effect of negative feedback on input and output resistance of current shunt. Now in the last 3 lectures I have explained the voltage series, voltage shunt, current series. Now in this lecture we will discuss the current shunt. Now for that what we need to do, first draw the block diagram. Now here this is an amplifier A and feedback network beta. Now output side current means what? The same current should get means what? Series connection we have to make. Now here this is nothing but I0, this is RL. So same current here we should get, that's why we are giving the series connection. Input side is shunt. Now I am taking this shunt connection over here. Now tell me, if I am taking this shunt connection at the input, so which source we need to apply? In a shunt only currents can be added and subtracted, voltages are same, that's why we have to take the current source. This is IS and this is IF and this is II. Now with this, now what can we write? A is equal to output by input. Output is I0, input is II. So this from this what can we write? I0 is equal to A into II. Now similarly beta is equal to what? Output by input. Now for this, what is output? IF. What is the input? I0. Now from this we can write IF is equal to beta times I0. Beta times I0. Now what is the input expression? II. II is equal to IS minus IF. Because of the negative feedback we need to subtract the feedback signal from the input source. Now here if I draw the equivalent diagram for the amplifier, so whatever is the input source, we have to represent the input with the only single resistor. That resistor name is Ri. Now coming to the output side, what is the parameter? Current. Output side current means what? We have to take the current source in parallel with the resistor. In parallel with the resistor, this is R0. And what is this current source? Current source is nothing but A into, what is the input parameter? Input parameter is II. So II. Now here this is II. Now what is the source we are applying? This is nothing but a IS. It is flowing in this direction. Now this is the IF, feedback signal IF flowing in opposite direction, and this is II. Now here up to this is the amplifier block diagram. For this input source I have applied. Now here we need to take the output load. Now how I am keeping the output load? RL. Current is flowing in this direction, I0. And what is the voltage over here? V0. Now if I am looking from this point, what is the resistance? This is the input resistance of the amplifier Ri. Now all are the current sources, current shunt, connected in shunt. So voltages are same. Here the voltage I am taking it as a V voltage. So V divided by II. Now if I am looking from this point, with means what? With the feedback, after the feedback if I am looking, then the resistance is I am denoting with the RIF, nothing but with feedback. Input resistance is V divided by IS. Now take the input expression II. II is equal to what can we write? II is equal to IS minus IF. Then how can we write IF is equal to, from the expression number 2? Now here from this, so beta I0, IS minus beta I0. Then again I0 is equal to, how can we write? A into II. So II is equal to IS minus A beta II. Now I am taking all AI terms together and taking AI out, then I will get AI into 1 plus A beta is equal to IS. Then II is equal to what can we write? II is equal to V divided by Ri into 1 plus A beta. Similarly, what can we write? IS is equal to V divided by RIF. Now both the side V is common, cancel it. Then RIF is equal to what can we write? RIF is equal to Ri divided by 1 plus A beta. With this what we understood? Now with the feedback, input resistance is reduced. Now this input side we are applying the current. Now current, when we are applying the current, the complete current should be applied to the should given to the amplifier means maximum current should drawn by this amplifier. So how much higher the input resistance, that much now here if the amplifier resistance is how much lower, it will make the lower resistance path and maximum current will flow through this Ri. Now with the negative feedback, what happened? Further this Ri is reduced, thereby what? It will draw the maximum current from the source, and after that it will amplify, and it will give after the amplification it will give the signal to the load. Now this is about the input resistance. In the current shunt is nothing but a current amplifier. In this input resistance is reduced by 1 plus A beta times. Similarly, we need to calculate the output resistance. Now what are the conditions to calculate the output resistance? Now from where, which point we are calculating, there we have to keep the terminals open. Now this is the V0. Now here if I am measuring the resistance R0 F is equal to what can I write? V0 divided by I0. V0 divided by I0. And also first condition is what? RL is equal to make it infinite, open, keep it open. And the second condition is what? IS is equal to 0. How can we make current source 0? Just by opening. If it is a voltage source, short it. If it is a current source, open it. Now this is the circuit diagram. Now from this, now for the input, if I am writing the expression II is equal to what can I write? Minus IF. So IF is equal to what can we write again? IF is equal to minus beta I0. Now here minus is there. So minus IF is equal to beta I0. Now this is the expression. Now again output side, if you see, this is the node. So apply KCL at the output. If it is a loop, we have to apply the KVL. If it is a node, apply the KCL at output loop. Now if I am taking the KCL at the output, entering currents is equal to leaving current. So I0 is equal to A into II plus, now here what is the current? We know the voltage and we know the resistance. V0 divided by R0. Now what can I write? II is equal to minus beta I0. So I0 is equal to minus A beta I0 plus V0 divided by R0. Now write all the I0 terms together, and now here I am taking I0 and taking common, writing together and taking common, and I will get I0 into 1 plus A beta is equal to V0 by R0. Now what we want? We want V0 by I0. So I0 you bring to this side and R0 to this side. So V0 by I0 is equal to R0 into 1 plus A beta. So what is this V0 by I0? R0 F. So R0 F is equal to R0 into 1 plus A beta. Now this is the expression for the output resistance in the case of current shunt. Now what happened with the negative feedback? The resistance, output resistance is further increased by 1 plus A beta. Now with that what happens? Now here whatever the current is coming, that will be drawn less and applied more to the load. So this is about the effect of negative feedback on input and output resistance in the case of current shunt feedback. Now if you see the all parameters, now effects of all parameters once again, now here I have given. So gain will reduce in all the cases, and bandwidth increases in all the cases, and here you can see distortion will be reduced. If the gain is reducing means what? Distortion will be reduced and noise will be reduced. Now coming to the input and output resistance, just we have derived in the case of input voltage series voltage shunt, current series current shunt. Now you can see, now wherever increase comes, there you have to multiply with the 1 plus A beta, and wherever decreases, so there you have to divide the term with the 1 plus A beta, 1 divided by A beta, multiply with the 1 divided by A beta, or just divide by 1 plus A beta. So thank you.